Today's topic is Lenz law. It is related to the direction of magnetic field produced by a coil or solenoid. Now the statement. When there is a change in magnetic flux related to a coil or solenoid, then the direction of EMF, induced EMF produced or induced current, it will always be in such a way that it will oppose the cause due to which it is produced. If there is a change in magnetic flux related to a coil or a solenoid, then the direction of induced EMF or induced current will always be in such a way that it will oppose the cause due to which it is produced. It is produced. This statement is not sufficient to explain how we will find the direction of induced current or induced EMF. Now, the explanation. This one is solenoid. A galvanometer is connected to this solenoid. Magnet is here. This one is north pole and this one is south pole. Magnetic lines of force will be in such a way the motion of this magnet is towards the coil. The distance between the magnet and coil is decreasing. So we can say there is attraction between the magnet and the solenoid. This is the reason due to which the current will produce, induced current will produce in the solenoid. According to Lenz, it is opposed. Means there must be repulsion between the solenoid and this magnet. It is only possible when the face of the solenoid, which is towards the magnet, will behave just like north pole. It will behave as north pole. This one is north pole. North pole is only possible when current flows anti-clockwise. This is the direction of current, induced current. Now we will write this one. Suppose north pole of a magnet is moving towards the solenoid. Towards the solenoid or the coil. The distance between the coil, the distance between the magnet and coil is decreasing. We assume that there is attraction between the magnet and solenoid. We can assume that there is attraction between the coil or solenoid and the magnet. This is the region due to which current will induce in the solenoid. It is the region due to which current will induce in the solenoid. According to Lenz, it is opposed. It is opposed. It means there must be repulsion between the coil and the magnet. It means there must be repulsion between the solenoid and the magnet. It is only possible when the face of the solenoid, which is towards the magnet, will behave as north pole. It is only possible when the face of the solenoid and the face of the solenoid which is towards the magnet will behave like a north pole. So the current in the solenoid will induce anti-clockwise. So the current in the solenoid will induce anti-clockwise. We can also explain the another method that north pole of the magnet is, this north pole is moving towards the solenoid in this direction. The distance between the magnet and the solenoid is decreasing. This motion is the cause of inducing the current. It means it is opposed according to Lenz. So the magnet must move away the solenoid. It is only possible when the face of the solenoid which is towards the magnet will behave as north pole. Same thing. Now if we change the direction of motion or the pole, if we change the direction of motion, this one is solenoid, it is galvanometer, this one is north pole of the magnet, and the south pole is moving in this direction. These are the magnetic lines of force. The distance between the magnet and the solenoid is decreasing, so is increasing. It means it is assumed that there is repulsion between the solenoid and the magnet. According to Lenz, it is opposed, so there must be attraction between the magnet and solenoid. It is only possible when this face, the face of the solenoid which is towards the magnet, it will behave as south pole. So the current induced in the coil will be clockwise. In this way, the flux will be just reversed. Here the direction of current is anti-clockwise. Now if we change the pole of the magnet, this one is solenoid connected to a galvanometer. This is magnet. Here is south pole, here is north pole. These are the magnetic lines of force coming towards the magnet. Here is motion. Again, the distance between the magnet and solenoid is decreasing. It is assumed that there is attraction between the magnet and the solenoid. There is attraction between this solenoid and the magnet. It is opposed according to Lenz, so there must be repulsion. Repulsion is only possible when this face of the solenoid will behave as south pole. So current will induce clockwise. It means if we change the pole or the direction of motion, then the direction of current induced in the solenoid will be reversed. In this way we can easily find the direction of induced current. Now induced charge. Magnetic flux passing through a coil having turn N, the magnetic flux passing through a coil having turn N, phi is equals to N B A cos of omega t. If omega t is 0 degree, then phi will be N B A. We can also write here that the value of E is d phi upon dt, d phi upon dt. Here E is induced EMF. If we combine the Lenz law and the Faraday law, on combining Lenz and Faraday's law, E becomes minus d phi upon dt. For n turns, E is minus n d phi upon dt. Here phi is, d phi is phi 2 minus phi 1. Phi 2 means final flux passing through the coil. Phi 1 is initial flux passing through the coil. if R is the resistance of the coil, R is the resistance of the coil, then E upon R, that will be minus N upon R into d phi upon dt. Here V upon R or E upon R, that's I, induced current. So induced current, that's I will be minus N upon R into d phi upon dt. The relation for induced current, or we can also write I into dt is minus N upon R into d phi, because I is Q upon T, or I into dt, that will be dq. Induced charge is induced charge, that's dq is minus N upon R into d phi, or dq is minus N upon R. Here is phi 2 minus phi 1. We can also write dq is induced charge is N upon R into phi 1 minus phi, the induced charge in the coil. Here dq is induced charge in the coil or solenoid.